Suppose we want to find the equation of a straight line passing through a given point with a given gradient. For example, suppose I've been given the point 2, 10, and I've also been given the gradient of 3, and I want to know this equation of the line passing through that point with this gradient. Well, you know that almost all straight lines have the equation y equals mx plus c, where m is the gradient of the line, how steep it is, and c is the point where it cuts the y-axis. So in this case, because we know the gradient already, we can write down straight away that the equation of the line is that y is 3x plus c, where c is still something we don't know. Now, if this equation holds for every point on the straight line, then in particular it's going to hold for the point we're given, so we can just put in those x and y coordinates to find out what c is. The y coordinate is 10, that's 3 times the x coordinate, which is 2, plus c. In other words, 10 is 6 plus c. In other words, c is 10 subtract 6, which is 4, so therefore the equation of the line is y is 3x plus 4. Not too tricky. Takes a little while to stop and do all this plus c part though. Let's look at a different way of doing this, which gives the same result but a bit quicker. So our alternative method is to write this down. Y subtract y1 is equal to m multiplied by x subtract x1. What do all these symbols mean? Well, the m is still the gradient that we're given. The x1, y1, they are the coordinates of the point that we're given. So in this case, I would just write down y subtract the y coordinate, which is 10, is equal to m, the gradient, 3, into x subtract the x coordinate, 2. Now, let's expand that out and see what we get. So y subtract 10 is equal to 3x subtract 6. Add the 10 to both sides to get that y is 3x plus 4. Same answer as before, a bit less working out involved. So I think that this way, the y minus y1 equals m x minus x1 method, is a bit quicker and easier. Let's just work through one more example using the new method. So suppose I want to find the equation of the line that passes through the point 4, negative 1, and which has a gradient of negative 2. So the new method suggests we just write y subtract y1 is equal to m into x subtract x1, which in this case means we'll be writing y subtract the y coordinate, which is negative 1. I think it makes it much clearer if you write that in a bracket, otherwise it will look very odd to have y minus minus 1 all in one long line. On this side we've got a gradient of negative 2 into x subtract the x coordinate, which is 4. Now, y subtract a negative 1 is the same as y plus 1. Expanding this side, we get negative 2x plus 8. Subtract the 1 from both sides to get that y is negative 2x plus 7. Quick, straightforward, no having to stop to work out c along the way. I would recommend that this is the method that you always use. Now, if you're interested, we're going to go on to prove why this works just as well as the other method. You don't have to understand this bit if you don't want to, you can just use that, but I think it's always a bit unsatisfactory just to do stuff without knowing why you're doing it. So let's go back to the other way of doing it. Suppose that we are given any point, and I'm not going to say what the coordinates of that point is, we'll just call them x1, y1, and we're given a gradient again, which I'm not going to say what it is, we're given a gradient of m. Then we know that the equation of the line, done the traditional way, is y equals mx plus c, where c is a point we haven't found yet. Now, what did we do when we had an actual example of this? We said that if this was true for every point xy on the line, then in particular it's true for the point that we're interested in. So if I put in a y coordinate of y1 and an x coordinate of x1, this is true. In other words, subtracting the mx1 from both sides, what is c? It is y1 subtract mx1. Well, let's go and pop that back into the original equation we had then. That means that y is mx plus c, which is this thing, y1 subtract mx1. Well, let's move this y1 over to the other side. Subtract it from both sides. That will give us y subtract y1. What's left on this side? There's an mx, and so we're subtracting an mx1. So, just factorising the m out of the right hand side, we've got y subtract y1 is m into x subtract x1. So it therefore does follow that we were right to say that we could just use this alternative method. And as I say, I suggest that you do that. It's much quicker and easier.